When multiplying fractions, there is no requirement for a common denominator. To multiply fractions, we just multiply straight across. Let's look at an example. What is 2/5 times 3/7? To multiply fractions, we multiply the numerators together and the denominators together. Simplifying the top and the bottom, our single fraction is 6/35. Let's look at another example. What is x minus 3 over x minus 6 times x minus 1 over x plus 6? Note that the 3 and 6 do not cancel in the first fraction. In fact, none of the x's cancel in any fraction either. As a reminder, for multiplying fractions, there is no need for a common denominator. To multiply these fractions, we multiply the numerators together and the denominators together. The previous example was fractions with numbers only. We still apply this process for fractions with variables. Simplifying the top and the bottom, we get x squared minus 4x plus 3 over x squared plus 6x minus 36. On bottom, the 6x and negative 6x undo each other. We're left with x squared minus 4x plus 3 over x squared minus 36. Let's look at another example. What is x minus 5 over x squared minus 100 plus 2 over x minus 10? To simplify adding fractions, we need a common denominator, just like we would if we had fractions without variables. Our work becomes easier if we first notice that the first denominator factors as x plus 10 times x minus 10. Let's rewrite it like this. Then we can leave the first fraction alone. For the second fraction, multiply the top and bottom by x plus 10. As we do this, the second fraction needs the original x minus 10 in parentheses. Without parentheses, the order of operations says something else. Now that we have a common denominator, we can combine the two fractions into one. The numerator is x minus 5 plus 2 times the quantity x plus 10. The denominator is x plus 10 times x minus 10. Distribute the 2 in the numerator. The denominator is x squared minus 100. We end with 3x plus 15 over x squared minus 100. No further cancellations are possible because the last operations on top and bottom are plus and minus, not times. Let's look at another example. What is x minus 5 over x squared minus 100 divided by 2 over x minus 10? Leave the first fraction alone and reciprocate the second fraction at the same time that we change the division sign into multiplication. Since we are now multiplying fractions, multiply straight across with no need for a common denominator. We have the quantity x minus 5 times the quantity x minus 10 on top, and the quantity x squared minus 100, close parentheses, times 2 on bottom. All parentheses here are needed due to order of operations. Expanding everywhere is an option, but that takes us further from a factored form. Instead, we factor the x squared minus 100 on bottom as x plus 10 times x minus 10. Now everything is a factor, so any common factor on top and bottom will cancel. Canceling the common factor of x minus 10 on top and bottom, we are left with x minus 5 over 2 times the quantity x plus 10. Since nothing further will cancel, it would be fine to leave the denominator like this or to expand by distributing 2.